The history of agriculture has essentially been a history of tillage in agriculture, and the culture of ploughing or tilling the soil to establish crops and manage weeds has been a central part of agricultural development worldwide. After World War I, agriculture began to be intensified to achieve greater output. Initially, this change process began in North America, but after World War II, it spread all over the world. From 1960 to 2000, no-till production was being tested in all continents by researchers and larger-scale mechanized farmers, and limited scaling began in the 1980s and 1990s. Conservation agriculture was first proposed in Spanish at the meeting in Morelia, Michoacán, Mexico, in 1997. The term was also adopted in 1997 by the Food and Agriculture Organization of the United Nations to describe sustainable production systems. This led Food and Agriculture Organization in 1998 to define the three interlinked principles of conservation agriculture at its first regional conservation agriculture workshop in Harare, Zimbabwe. 1. Continuous minimum or no mechanical soil disturbance. 2. Maintaining a permanent mulch cover on the soil surface. 3. Diversification of species in the cropping system. The mindset that is driving the global conservation agriculture community of practice defines conservation agriculture as an ecosystem approach to regenerative sustainable agriculture and land management based on the practical application of the context-specific and locally adapted three interlinked principles described earlier. Conservation agriculture areas in different countries were put together by Food and Agriculture Organization and made available through Aquadstat until the year of 2013 to 2014. The information on the global spread of conservation agriculture has been updated periodically, such as in the year of 2008 to 2009, 2013 to 2014, and 2015 to 2016, and is available at the Conservation Agriculture Global website. This video will provide the details of the update on the uptake and spread of conservation agriculture around the world at the global, regional, and national levels for the year of 2018 to 2019 and elaborates on some of the successful experiences in conservation agriculture adoption and spread. The transformation of conventional tillage-based agriculture began in the 1930s after the Dust Bowl that shook the farming communities in the Midwestern United States, causing the scientific community to rethink what was not going right with farming, particularly about soil conservation. Minimization of soil disturbance with stubble mulch was a breakthrough in the understanding of how the objective of crop production intensification could be combined with the objective of soil and water conservation at the practical level by farmers. In the late 1960s, pioneer farmers showed that no-till seeding through stubbles and crop biomass cover was the way to avoid or eventually reverse soil degradation and erosion. The global total conservation agriculture cropland area in the year of 2018 to 2019 was approximately 205.4 million hectares, corresponding to about 14.7% of the total global cropland. This represents an increase of 98.9 million hectares from 106.5 million hectares in the year of 2008 to 2009, with the spread being more or less equally split between the global south and the global north. The global conservation agriculture cropland increased by some 48.6 million hectares or 31% since the year of 2013 to 2014 from 157 million hectares, and some 25 million hectares or 13.9% since the year of 2015 to 2016, and from 180 million hectares to 205.4 million hectares in the year of 2018 to 2019. Overall, the increase in the global conservation agriculture cropland area since the year of 2018 to 2019 has continued at an annual rate of approximately 10 million hectares per year, from 106.5 million hectares in the year of 2008 to 2009 to 205.4 million hectares in the year of 2018 to 2019. The decade of the 1990s is considered the decade when conservation agriculture took off. During the first and the second decades of the new millennium, conservation agriculture uptake by farmers spread out to Africa and Asia while it continued spreading in the Americas, Europe, and Australia. Smallholders had already been adopting conservation agriculture systems, both manual and mechanized, in the tropics in South America in the late 1980s and 1990s, and smallholders in Africa and Asia also began to adopt conservation agriculture systems during the 1990s and the first decade of the new millennium. The millennium opened with the First World Congress on Conservation Agriculture, which was held in Madrid, Spain. By 2010, more than 105 million hectares were under conservation agriculture cropland systems across 36 countries, covering all continents and most land-based agroecologies. During the period from 1990 to 2010, the global uptake of conservation agriculture was approximately 9 million hectares per year. During the 2010 to 2020 decade, the rate of global uptake increased to 10.5 million hectares per year, reaching more than 205 million hectares in 2019 across 100 countries. The expansion of conservation agriculture uptake continues to be largely farmer-driven, and an increasing number of governments are now providing policy and institutional support to the uptake of conservation agriculture cropland systems in addition to private sector machine and service companies. The three interlinked principles of conservation agriculture are universally applicable in all land-based crop production systems on all continents, on all farm sizes, and with all types of farm power. The three principles emulate nature, in which mechanical soil disturbance does not occur for vegetation to propagate and establish. Where vegetation growth is possible because of moisture availability, biomass produced always covers the ground and organic matter is converted into compost mulch on the ground surface and is incorporated into the soil through microorganisms and mesofauna. As one of the most important representatives of mesofauna, earthworms and termites play an important role in ingesting the biomass and mixing it with soil mineral particles to produce nutrient-rich worm casts and excreta. Microorganisms also produce their carbon-rich compounds, which help to bind soil mineral and non-mineral particles into stable aggregates that improve soil structure and porosity, water infiltration and retention, and soil aeration. Ecosystem services are ecological and biological or organic services provided to society by nature. They can be categorized into supporting services, regulating services, provisioning services, and cultural services, but in nature, they are all interconnected. These services operate at the field and landscape levels. A major difference between conventional tillage agriculture, which uses the plow and several tillage operations, and conservation agriculture is in their ability to harness ecosystem services in the fields for production and across landscapes for society and the environment. In conventional tillage agriculture, soils are degraded, and all soil health functions are debilitated and prone to dysfunction. At the ecosystem level, ecosystem services at the field and landscape levels generate regional, national, and international level services for society, including supporting services for biodiversity systems such as primary vegetation, wildlife habitats, and migration systems, general circulation of the atmospheric regulation, thermal and moisture regulation in climate and weather systems, and large-scale nutrient, water, and carbon cycling. Cultural services operate in terms of the conservation area for wildlife and biodiversity, cultural and ecological tourism, and natural historical sites that have spiritual value. Global scientific and empirical evidence, as well as the extent of the global spread of conservation agriculture, shows that conservation agriculture is a valid alternative agricultural paradigm that is capable of addressing the weaknesses in the dominant tillage-based green revolution paradigm. Contrary to tillage-based farming systems, natural resources such as soil, water, and biodiversity are not degraded in conservation agriculture systems but enhanced and improve over time. By reducing production costs while stabilizing, maintaining, or even increasing yield levels, conservation agriculture improves the economic sustainability of farm households. Through diversified production systems, conservation agriculture supports the local supply of diversified food, gives small family farmers and rural entrepreneurs business opportunities, and enhances with this the social structure of rural areas, reducing the trend of urbanization. In this way, conservation agriculture is addressing sustainability in its three main areas: environmental, economic, and social. The global burden of chronic crises includes food insecurity, climate change, loss of biodiversity, environmental degradation, unsustainable diets, and human ill health. Conservation agriculture systems have a role to play in addressing all these crises. Increasingly, conservation agriculture must be seen to be a central part of sustainable food systems and sustainable environmental management. It is appropriate to remember that, like climate change, the general global public is not aware that the ongoing soil and biodiversity degradation caused by tillage is putting the survival of humankind on this planet at risk. President Franklin Delano Roosevelt in the USA once said, "The nation that destroys its soil destroys itself." We can now also add, the society that destroys its soil and biodiversity destroys itself and the planet.